Hello, my name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to be exposed to the ideals presented in the Binomial Theorem, which is a really great tool for when you have to deal with binomials that have higher powers, to the 52nd power, to the 10th power, whatever. So without wasting time, let's move into this. Now, the first thing I want to do is I need to review a little bit of information. We have talked about in the past something called the combination formula, which essentially is a way to find out how many possibilities there are in terms of selecting a certain number of items when you don't care about the order. And so, for example, the formula is as follows. The formula is as follows. And so we have here a combination n and r like so, and it's going to equal n factorial over r factorial minus the quantity of n minus r factorial. This is the secret here. And we use this combination formula to find the coefficients inside a binomial when we're trying to work it out. And what I mean by coefficient is the number in front of a variable or in front of a set of a combination of variables, several variables that you multiply them by. So for example, and I know this is a review for some of those of you who are stronger at this, when you have 2x, well, the 2 is the coefficient and the x is like the variable. And so we use this guy right here to find the coefficient inside some binomial terms when we're trying to work them out. Now, having said that, what I'm going to do now is I'm going to show you a very simple binomial. I'm going to work it out the traditional way, and I'm going to try to point out some of the patterns in them. And then once we see these patterns, what we're going to do is that we're going to solve the same binomial using the binomial theorem so that you can see how it can give you a shortcut. So here is my basic one, and this is not that hard. So you have x plus y squared. Well, that's not very deep at all. It's just x squared plus 2xy plus y squared. Now, this is what you normally see. Now, what I'm going to do now to make it easier for you to see the patterns is I'm going to write out everything. And what I mean by everything is going to make more sense when you see it. So let me go ahead and demonstrate that to you. So I'm going to have x squared, and then I'm going to have y to the 0 power, because that's basically what's happening. And I'm also going to put a 1 here, okay, because that's the same thing. So this is going to be a 1. It's kind of ugly, but trust me, that's a 1. Plus 2x to the first power, y to the first power, plus 1x to the 0 power, y to the second power. So this is the same thing, but we're writing out stuff that we don't necessarily need. You know that anything raised to the 0 power is 1, so there's no need. But trust me, there's a reason that we're doing this. Now, there are several things that I want to point out to you that maybe you've noticed before, but maybe not. If you look carefully, you can see that for my x variable, for my exponent here, it always decreases in value. So it starts at 2, goes to 1, goes to 0. So for the x, it's always decreasing. For the y, you can clearly see that it increases. It goes from 0 to 1 to 2, like that. So the y increases. And then the exponent is kind of mysterious. It goes from 1 to 2, back to 1. That's because we're going to use the combination formula to solve that, and I've already introduced that to you. Now, there's something else that I want to show you here, and again, it's in relation to the combination formula. And so, like I told you before, the formulas on the previous page, what's happening is this. You have essentially two choices here. So in terms of figuring out the combination. And so you have two choices. It could be, 2 or 1. I guess that's your two choices. And you can see here, we chose 2 this time. We chose 1 this time. This time we chose 2. This time we chose 1. That's what's happening here. And so if we were to work this out using the combination formula, and again, I'm talking about this coefficient in the front. This is what's happening. So let's take the first one. You are basically looking at a situation where you have your sample size, or the larger you can be, is 2, but you chose 0. That's what's happening right here, and that's how you got the 1. Now let me work this out for you. So when I say that, I mean the following. I'm saying the combination is 2 choose 0. And so that looks like the following. 2 factorial over 0 factorial times the quantity of 2 minus 0 factorial. And this works out to be 2 times 1. 0 factorial is just 1. And then 2 minus 0 is going to be 2. Let me put a times here. Times 1. So these cancel, and you're literally left with 0 out of 1. And so 0 out of 1 is nothing, which is why I put a 1 here. You don't put a 0 there. That would, again, you're multiplying by 0. That would be a disaster. But this is essentially nothing. This is nothing. That's why there's nothing there. Okay, let's take a look at the second one. We have a 2 here. But in this situation, what we're doing is as follows. We are doing, let's see here. We are doing 2 choose 1. So I need a little bit more space here. 2 choose 1. And so that's going to be 2 times 1 times the quantity. We're choosing 1, so that's going to be 1 factorial times 2 minus 1. All right, so we end up with 2 times 1 over 1 times 1. That's what we have here. And so that's going to give us 2. And so this is why we have a 2 right here. You can see that right there. That's why we have a 2. And so for the last one, if I want to really force myself to put everything on one screen, we're going to have 2 choose 2. So 2 choose 2 is going to be 2 times 1. And then our R is going to be 2 times 1. And then inside this is going to be 2 minus 2, like so, factorial. And so we end up with 2 over here. And then let's see here, 2 times 1 is 2. And then 0 factorial is 1. So we end up with 2 again. And you can see we get that nice 1 that goes right here. Now, what is happening, if I had to show you the pattern, is this. It starts out with 2, 0, 2 choose 0, then 2 choose 1, then 2 choose 2. So the top number always stays the same, but the bottom number increases by 1 each time. That is what was happening with each combination formula. Okay, now it's the big moment of truth here. Here we go. So I'm going to show you the binomial theorem so that we can have the experience of working it out with the binomial that we just saw, and then we're going to work it out again with a more complex binomial. So here's what it looks like. Everything I just showed you is kind of what's happening when you use the theorem, which is a little kind of weird here, but just be patient. This will all come together in a moment. So we got x plus y raised to the nth power, whatever that is. And then after that, we have here summation sign, because we're adding everything together. K is going to start at 0, and then we're going to go to the n, and then we're going to have our combination right here. And then after that, we're going to have x to the n minus k, and then y to the k. And because this is summation, this will of course go on until we're done. Now, let's use this particular formula right here that we have right here, this summation equation, if you will, to calculate our friend here, x plus y to the second power. So here's what this looks like. All right, let me change the color. So I'm going to start with this nk. So I'm going to have 2 choose 0, like I already showed you. And then I'm going to have x, and then my n is 2, and my first k is 0, like so. That's what it looks like. And then I'm going to have my y here, and that's going to be to the 0 because I start with 0. I hope this is all clear. Plus, then I'm going to have 2 choose 1, like so. And then I'm going to have x to the 2. Now my k is 1, minus 1. And I'm going to have y to the first power, like so. Then I'm going to add 2 choose 2. And then I'm going to have x to the 2 minus 2, because now k is 2. And then I'm going to have y to the second power, like that. And so all this should look familiar. So if we do 2 choose 1, we've calculated that before. That's essentially 0, so we ignore it. So I end up with x. Well, let me change the color for you. I end up with x squared and then y to the 0 is 1, so I'm just going to leave that out. So plus, now when I have 2 choose 1, if you remember on the previous screen, that was going to be 2. If you have any questions, you can calculate that yourself. And so I'm going to have a big 2 here, and then x squared to the minus 1 is going to be just x, and then y to the first is just going to be y, like that. And then plus, now I have 2 choose 2, that's essentially 1, so I can leave that blank essentially. And then x squared minus 2, or x to the second power minus the second power, is going to be x to the 0. That becomes 1, we leave it out, and we end up with y squared. So you can see that we essentially got the exact same answer in a much more efficient way. Now again, for a binomial that's only raised to the second power, it's not that complicated. But what if we had something really, really crazy? For example, what if we had something raised to like the 5th power, which still isn't quite that bad, but it can be quite the headache. So x plus y to the 5th power. Now we can multiply this 5 times, and it could be very easy to make a mistake, or we can use our friend, the binomial theorem, to deal with this. So why don't we do that? So let's do this. So what I need to calculate is as follows. I have to go 5 choose 0. Oh, I might need more space than that. So how about this? 5 choose 0, and then we're going to have x to the 5 minus 0. X to the 5 minus 0, and then we're going to have y to the 0, like this. Then it's going to be plus 5 choose 1, and it's going to be x to the 5 minus 1, and we're going to have y to the 1. I hope this is starting to make sense. You can see the patterns. Plus, we're going to have now 5 choose 2, and it's going to be x to the 5 minus 2, y to the second power. Plus, moving down here, we're going to have, let's see here, 5 choose 3, and it's going to be x to the 5 minus 3, and it's going to be y to the third. And then we're going to keep going. Let's see here. We're going to have x plus x, plus 5 choose 4 is going to be x 5 minus 4, and then it's going to be y to the 4th power. And then after that, plus again, we're going to have 5 choose 5. So now we're going to have x to the 5 minus 5, and we're going to have y to the 5th power. Okay, so you can do all the combinations on your own time. I'm sure you would love to do that. But if we were to run this, we would essentially get the following answer. So we get, as a drum roll, you could check this yourself, x to the 5th power plus 5x to the 4th power y, like so, and then plus 10x to the 3rd power y to the 2nd, y squared, plus another 10x to the 2nd power y to the 3rd, and then looks like after that plus 5x y to the 4th, and then plus at the bottom y to the 5th. So you can see that, this is quite the disaster, a whole lot of work. And again, you have to work out the combos on your own time. Otherwise, this video would literally be 30 minutes. But you can see how your familiarity with the binomial theorem and your familiarity with the formula for finding combinations can be used together to find out how to work out very long and complex binomials. So we're going to try to review what we talked about and wrap up this video. So in this video, we looked at how to find first different combinations. We reviewed how to do that. And we used our knowledge of how to find combos to figure out what the coefficients are in binomial terms. And that led to our example here. In this one, we worked out things the long way without knowing the theorem yet to get an idea of what was going on. So what is basically happening is that the first term of your variable, which for us most of the time is x, it decreases in value in relation to the binomial theorem. And then the second term in this example, which is y, it increases in value in terms of the exponent. And then for the coefficients that go in front of these terms, you have to calculate each one using the binomial theorem. And so essentially you start with your highest value and then the lowest value possible. And then what happens is that the top number stays the same, but the bottom number increases by 1 for each term until you work it all the way out to 2 over 2 or 5 over 5, whatever. So, and again, this screen right here kind of shows you what's going on with this. Now, again, the 2 comes from the number of the exponents. So that's what's happening there. So if I have something like that starts with the 4 raised to the 4th power, it would be 4, 0, then 4, 1, then 4, 2, then 4, 3, then 4, 4. That's what happens. And then with the 5th power, it'd be 5, 0, 5, 1, 5, 2, 5, 3, 5, 5. 5, 4, then 5, 5. That's what's happening there. And so then after that, we looked at the actual binomial theorem itself. And so when you have, x plus y to the nth power, you have the summation of k to n with the combination formula n over k with x to the n minus k, y to the k, etc. And then we worked it out here. You saw this guy before, x plus y to the 2nd power. We saw this before, and we worked it out using the the binomial theorem as shown below. Got the same answer. And then we did one that was even more complicated, and you can see the nightmare that's at the bottom. You could check it on your own time as it is. So I hope this video was useful for you. It was long and challenging. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.